Ready to have your mind stretched across the cosmos? Here are 10 incredible facts about the universe that you probably didn't know. Let's dive in. Number 1. There's a cloud of space alcohol. Yeah, you heard that right. There's an actual cloud of alcohol floating out in space. It's called Sagittarius B2, and it's just hanging out near the center of our galaxy, about 390 light-years from the Milky Way's core. But this isn't some tiny cosmic cocktail. This cloud is huge, about 463 billion kilometers across. That's big enough to hold more than 400 trillion pints of beer. If you tried to drink it all, well, you'd be passed out until the next Big Bang. The type of alcohol in the cloud is ethyl alcohol, the same kind that's in wine, whiskey, and your weekend plans. But here's the kicker. It's mixed with other chemicals like methanol, glycolaldehyde, and a bunch of other stuff that probably make it taste like flaming nail polish. Scientists found it using radio telescopes, picking up the unique signal that alcohol molecules give off. It's not drinkable, obviously, but still, it's wild to think the universe just casually brews booze in space. So next time you're having a drink, raise a glass to Sagittarius B2, the biggest bar in the cosmos. Number 2. Neutron stars are like atomic, city-sized monsters. All right, picture this. A star way bigger than our sun runs out of fuel. It collapses in on itself during a massive explosion, a supernova. What's left behind is a neutron star. And it's insane. This thing crams more mass than the sun into a sphere just about 20 kilometers wide. That's like the size of a city. To give you an idea of how dense that is, if you scooped just a teaspoon of a neutron star, it would weigh around 1 billion tons. Yeah, 1 billion. That's like the weight of a mountain in a spoon. The gravity? Off the charts. And because of how compact they are, some neutron stars spin super fast, like hundreds of times per second. They're called pulsars when they shoot out beams of radiation while spinning, kind of like space lighthouses. So yeah, they're small, deadly, and spin like crazy. Basically, if the universe had power-ups, a neutron star would be the maxed-out stats kind of deal. Number 3. The universe has no center and no edge. Okay, this one messes with your brain a little. People often imagine the Big Bang as a huge explosion, like boom, stuff flying out from a single point into empty space. But that's not really how it went down. The Big Bang didn't happen in space, it created space. It wasn't an explosion in the universe, it was the rapid expansion of the universe itself. Which means there's no center, no starting point you could fly to, and no edge where the universe ends and there's just nothing beyond. It's all just more universe. Imagine blowing up a balloon. Every point on the surface moves away from every other point, but there's no special center on the surface itself. That's kind of like how the universe expands, but in all directions, in 3D, and without anything outside the balloon. And get this, wherever you are in the universe, it looks like everything is expanding away from you. So technically, you could say you are the center. but so is everyone else. It's weird, it's wild, and it completely breaks how we usually think about space.
Number 4. You're made of stardust.
Literally. All right, get ready for something poetic. You, me, everyone you know, we're basically walking star residue. Here's how it works. The early universe only had the lightest elements, mostly hydrogen and helium. But stars? They're like nuclear fusion factories. Inside them, lighter elements get fused into heavier ones, like carbon, oxygen, calcium, iron, all the building blocks of life. But those elements don't just stay locked inside the star forever. When a massive star dies, it goes out with a bang, a supernova. That explosion spreads all those heavy elements across the galaxy. It's cosmic recycling on the biggest scale you can imagine. Eventually, all that stardust clumps together again, forming new stars, planets, and, yeah, you. The carbon in your DNA, the iron in your blood, the calcium in your teeth, all cooked up in the heart of a long dead star. So next time someone says, "You're special," they're not wrong. You're literally made from the remains of ancient stars, billions of years old. Galactic legacy in human form. Pretty badass, honestly.
Number 5. Time moves slower in strong gravity.
All right, here's one that sounds like straight-up sci-fi, but it's 100% real. Time doesn't tick at the same speed everywhere in the universe. According to Einstein's theory of relativity, the stronger the gravity, the slower time moves. This is called gravitational time dilation. So let's say you're hanging out near a black hole, where gravity is ridiculously intense. To you, everything feels normal. But if someone was watching you from far away, like from Earth, they'd see you moving in slow motion. Your clock would literally be ticking slower than theirs. And it's not just theory. We've actually measured this. Astronauts on the International Space Station age a tiny bit slower than people on Earth because they're farther from Earth's gravity. Not by much, but it's real. Now, scale that up to something like a supermassive black hole. If you orbited close enough, you could spend a few hours there, come back, and years might have passed for everyone else. It's like time travel, just not the kind you can control easily. So yeah, gravity messes with time. The universe doesn't just stretch space, it stretches when things happen too. Wild, right?
Number 6. Dark matter makes up most of the universe, but we can't see it.
So here's the deal. Everything we can see, planets, stars, galaxies, you, me, that's only about 5% of the universe. The rest? Mostly stuff we can't see. And a huge chunk of that is something called dark matter. Dark matter doesn't give off light. It doesn't reflect it, absorb it, or interact with electromagnetic waves at all. It's completely invisible. But we know it's there because of how galaxies behave. See, when astronomers look at galaxies spinning, they notice something weird. The stars at the edges are moving way too fast, like they should be flying off into space. But they're not. Something is holding them together, something with mass. That something is dark matter. It's like an invisible scaffolding that helps galaxies form and stay stable. Without it, the universe as we know it probably wouldn't even exist. What's it made of? Nobody knows yet. It's one of the biggest mysteries in physics. So, yeah, most of the universe is filled with this ghost-like stuff we can't see or touch. But without it, we wouldn't be here. Kinda spooky. Kinda amazing.
Number 7. The biggest known star wouldn't even fit in our solar system.
All right. You think the sun is huge? It is compared to Earth, but in the cosmic scale, the sun's actually kind of a lightweight. Meet UY Scuti, one of the largest stars we've ever discovered. It's what astronomers call a red supergiant, and it absolutely dwarfs our sun. How big are we talking? If you replace the sun with UY Scuti, its surface would stretch out past the orbit of Jupiter. That's over 1,700 times the diameter of the sun. To put it another way, if UY Scuti were a basketball, Earth would be a grain of salt. Yeah, it's that massive. And here's the wild part. It's not even the most massive star, just the largest in volume. It's big and bloated, like a dying beast in slow motion. Stars this size are unstable and don't live long. They burn hot, fast, and go out with a bang, probably as a supernova, or even a black hole. So while it might not look like much through a telescope, UY Scuti is a literal giant among stars. A reminder that out there, in the deep reaches of space, size limits just don't exist.
Number 8. Rogue planets are just drifting through space. So, we're all familiar with planets orbiting stars, right? Like Earth goes around the Sun, Jupiter orbits out beyond us, and so on. But not all planets play by those rules. Some planets are just out there, drifting. No star, no orbit, just floating alone through the galaxy. These are called rogue planets, and they're honestly kind of mysterious. Scientists think they got kicked out of their original solar systems, maybe during a chaotic collision or by getting too close to a bigger planet that flung them out like a slingshot. Now they just wander through space, cold and dark, with no sun to warm them. And get this, there could be billions of these rogue planets. Some estimates say there might be more of them than stars in the Milky Way. Entire worlds just lost in the dark. Some might have moons, thick atmospheres, or even subsurface oceans warmed by internal heat. We really don't know. But the idea that there are untold numbers of lonely planets out there, it's kind of haunting and kind of beautiful.
Number 9. The coldest known place isn't in deep space. It's in a lab on Earth. All right, when you think of the coldest place in the universe, you probably imagine deep space, like far away from any stars, just pure frozen darkness. And yeah, space is cold, around minus 270 degrees Celsius, just a few degrees above absolute zero. But here's the twist. The coldest known spot? It's not out there, it's right here on Earth. In a lab, scientists managed to cool a cloud of atoms to a few billionths of a degree above absolute zero. That's the coldest temperature theoretically possible. At that point, atoms pretty much stop moving altogether. They enter a strange quantum state called a Bose-Einstein condensate, where multiple atoms start acting like one single superatom. To do it, they used a combo of lasers and magnetic fields, basically trapping and slowing down atoms with light. It's some next-level science fiction stuff, except it's real. So yeah, humans created a patch of matter colder than the empty void of space. Incredible what curiosity and a particle lab can do.
And number 10.
The observable universe is 93 billion light-years wide, but only 13.8 billion years old. Okay, here's one that seriously bends your brain. The universe is about 13.8 billion years old. So you'd think the farthest we could see is 13.8 billion light-years away, right? Makes sense. Except it's way bigger than that. The observable universe is actually around 93 billion light-years across. Yeah, more than 6 times wider than its age in light-years. How does that even work? It all comes down to the expansion of space itself. When light left those distant galaxies billions of years ago, they were a lot closer. But in the time it's taken that light to reach us, the universe has stretched, and those galaxies have been carried farther away. So what we're seeing is ancient light from galaxies that are now much farther than 13.8 billion light-years away. It's like looking at a photo someone mailed you billions of years ago, except by the time it arrives, they've moved to another continent. And that's just the observable part. What's beyond that? No one knows. Could be more universe, could be something else entirely. So yeah, when you look up at the night sky, you're seeing a snapshot of a much smaller universe, from a time when it was just getting started. And there you have it, 10 mind-bending, reality-warping facts about this universe we're floating around in. From clouds of cosmic booze to rogue planets just doing their own thing in the dark. It's clear we've only scratched the surface. The universe is huge, it's weird, and honestly, it's kind of beautiful in how much it refuses to make sense sometimes. So next time you look up at the night sky, just remember, you're standing on a tiny rock, orbiting an average star, in a galaxy that's one of hundreds of billions. And somehow, you're here, thinking about it. That's pretty amazing in itself. If you enjoyed this little trip through space and time, hit that follow or subscribe button. There's way more cosmic wonder out there, and we're just getting started. Catch you in the next one. Stay curious.